Hello friends, in this session we are going to understand equipotential surface and its properties. Now first let us understand what is the equipotential surface. The surface on which the electric potential at every point is equal is called as equipotential surface. So what is equipotential surface? It is a surface at which if you find electric potential at any point on that surface, you will find that the potential is same, and that surface is called as equipotential surface. So first we will define equipotential surface. So a surface having same potential at every point a surface having same potential at every point is called as equipotential surface. A surface having same potential at every point is called as equipotential surface, right? Now, this surface can be imaginary, it can be on empty space, right? Or it can be the surface of the conductor itself. So it can be what? In empty space, that means it can be an imaginary surface, or it can be on the surface of the conductor itself, right? Now let us understand some properties of equipotential surface. First properties. First property is that if the charge move on equipotential surface, no work is done when the charge is moving on the equipotential surface. So that means if there is a surface, equipotential surface, and if the charge is moving on the equipotential surface, no work is done while moving the charge from one point to another point on equipotential surface, right? So no work is done in moving the charge from one point to another on equipotential surface. Okay, now we will understand these properties one by one in the examples that I will be giving you in the next session. Okay, so this is number one property. Number two property. And second property says that the electric field lines should always be normal to the equipotential surface. So what does it says? That electric field lines should always be normal to the equipotential surface. That means if we have an equipotential surface, electric field lines should always be perpendicular to that surface. Okay, so electric field lines should always be normal to equipotential surface. Okay, this is the second very important property. Third property says that the equipotential surfaces are close to each other or are closer to each other where the electric field is stronger. So in the region where the electric field is stronger, the equipotential surfaces are close to each other. Okay, so this is the third property. Equipotential surfaces are close to each other at a region of stronger electric field and vice versa. So that means a region at where the electric field is not stronger, is weaker, the equipotential surfaces are widely spreaded. They are not close to each other, they are widely spreaded, right? So this is the definition of equipotential surfaces and the properties of equipotential surface, right? So in the next session, we are going to take examples of equipotential surface and then understand these properties and the definition of equipotential surface in detail, right? I hope you have understood this session. Thanks a lot.